Hello, my name is Silvano Coriani. I work in the Azure Postgres team, and I'm here to present about high availability and disaster recovery for Azure Database for Postgres. This is an interesting topic, especially if you need or want to set up Postgres in a mission-critical deployment and setups and maintain your business ability to respond to your needs while there's a disaster or anything else impacting your system. Okay, so this is the fundamental problem that we try to solve, right? Business continuity, which means maintaining your organization's ability to perform its functions or quickly resume after a big disruption that can be hardware or software failure, natural disaster, anything which is trying to basically keep your business down. And when we talk about business continuity, there are two key metrics. One is recovery time and objective, and one is a recovery point objective. And we are basically defining those metrics based on fundamental events that can impact your system. The first one is when we basically took the last good backup of our business data, and when the system becomes unavailable, right? And next one is when the system goes back online and fully recovered. And we are basically referring to recovery time interval or objective, the interval between when the system goes down and when it's fully recovered, while the recovery point objective is between the last consistent backup or data point that we have in the system and when the system basically goes off. And in most cases, there's a chance that this is also represented the interval of data, that the portion of the data that you can lose if basically the system was not saving this consistently over time. Redundancy, so creating additional copies or additional systems is the way to actually enable high availability scenarios or disaster recovery. And high availability, generally speaking, we refer as a single physical site where we are basically duplicating the data and keeping them in sync through replication, usually physical replication and synchronous one. And but this basically is the fastest and with the setup with the smallest recovery time and recovery point objectives possible. Although it's typically quite expensive because we are fully duplicating the system. Disaster recovery enters when we want to protect from losing an entire site, right? That can be, highly available, but if we lose both copies, again, we cannot process any data anymore. So with disaster recovery, we generally have a secondary site with, again, a copy of our system, which is in sync, but generally speaking is asynchronous due to the additional latency that is basically involved in transferring data from the primary to the secondary. So in this setup, we are actually increasing RPO and RTO and still have a pretty expensive setup because typically this is paired with the high availability on the local site that we were referring to. A third cheaper option for recovering a system can be relying on just pure backups, right? And backups can be shipped from a primary location to a secondary location. And in that secondary location, we don't have any system active up and running, but we just recreate the system all the time. In this case, we have very high RTOs. We can have potentially high RPOs as well, but at a very cheaper price. So in Azure, thanks to the architecture that we have in our data centers and regions, we can accommodate actually all three examples that we were referring to: high availability with different locations within the single region, with low latency for maintaining local HA. We can have parent regions that can where data can be replicated asynchronously between regions while still maintaining data residency requirements, like for example within the EU or within the US and such. And we can ship backups between parent regions in a synchronous manner. And in most cases, this actually is pretty automatic based on Azure storage. Availability zones are another super important aspect in creating these highly available solutions. The combination of availability zones and parent regions is giving us the ability to set up mission-critical applications and tolerate, for example, losing an entire data center and still keep our business up and running within the other two availability zones in a system. Right, and we can go up to 4 nines easily with the combination of hardware and software. So for Azure Database for Postgres specifically, this is the combination of the two technologies that we were referring to. So we can have our local kind of primary instance of Postgres sitting in a given availability zone in our region 1, which gets synchronously replicated to a secondary copy or hot standby server within the same region in a different availability zone. So we can tolerate losing an entire data center here and basically moving to the secondary zone without any particular impact because we are synchronous, so we don't have any data loss in this regard. And we see also another region here where we are asynchronously replicating data, leveraging multi-region read replicas. And in this case, we have a synchronous replication because of the additional latency, but we can then promote potentially our secondary copy here to a new primary in case we are actually losing the entire region over here. And so the combination, and last but not least, in Azure Database for Postgres, we are storing our backups into geo-redundant storage, which gets automatically and transparently replicated to a parent region so that we can restore our systems in that region even kind of later on to recover from bigger disaster. So if we start from a flexible server architecture here, this is a deployment without any HA. So we are basically deploying our Postgres instance in a Linux VM using managed disks to store data and logs. This system gets backed up in Azure redundant storage where essentially data will be available on different availability zones within the same region, right? We want to make this locally highly available. So the next step would be to actually enable high availability on this primary instance that we have. And this will automatically set up a standby server in the same zone or in a different zone. We are selecting a different zone here to rely basically on availability zones for full data center loss. And we have a synchronous replication within the two to make sure that basically there is a minimal or even zero data loss between our primary and our secondary. And most importantly, we can transparently and automatically failing over in case there's a problem on our primary to our standby server here, as we will see in a second in our demo. So this is a pretty simple but very efficient and highly available setup that we can enable with few steps in our deployments.
Okay, let's take a quick look at our demo scenario here. In the first part, we are going to demonstrate local high availability. We have our region 1 here and our primary instance, which is sitting in availability zone 1. And we have a hot standby server in different availability zone in our setup. And we have synchronous replication between the two. So what we will demonstrate here is how we can fail over almost transparently between the primary and the secondary, and we will see how the application will react to this. Let's take a quick look at how our environment looks like in the Azure portal. So we have two instances of flexible server in this particular setup. One is located in Italy North, and the second is in Switzerland North, representing the two regions that we have deployed our resources in. If we look at the primary one, we can see that right now is in availability zone 1 within our Italy North region. And if we take a look at the high availability blade here on the left, we have confirmed that we have high availability enabled for this one, and that high availability mode is zone redundant, so that a standby server is available in a different zone compared to the primary, that the availability status is healthy, and these are the primary and the standby availability zone positions, right? At the same time, we have a secondary instance here, which is in a different location. So we can see, this is the secondary, and the way we actually have set up this is here in the same blade of the primary, we can see replication blade, and in the replication blade, we see that we have actually our primary and our secondary replica that are part of the same replica set, and in the two different regions. And we can see some additional information, like as an example here, the read replica lag between the two, and the fact that both of them have Microsoft Entra or Azure Active Directory authentication enabled for the two. We also have created here the virtual endpoint. Virtual endpoint is a single connection point from our applications that can switch then between primary and secondary in a kind of transparent manner without the need for changing the connection string the moment we will fail over from our primary to our regional replica in a different location. Okay, but it's very unlikely that in production we are creating our environments here in the portal. So let's take a look at how we can do this through coding and scripting. We are using here Azure CLI commandlets to set up our environment. We can see first the server creation here, first instance creation. This is our primary actually, and we have high availability attribute specified here as zone redundant. Our primary is in zone 1, while our standby zone is number 3. Right, with this command, we are actually setting up our primary instance with high availability enabled within our single region. We are here enabling Azure Active Directory or Entra authentication, so we don't need to use password anymore. In fact, we have disabled password authentication for this particular instance. And we are here creating the new replica in a different geography, in a different region. Right, so we can see, the command is replica create. We are creating the secondary replica here with the source server specified as the primary, and we are placing this in zone 3 of the new region. And we are also creating here the new virtual endpoint, which is basically abstracting primary and secondary behind a single virtual endpoint name here. Okay, so this is for scripting and imperative creations. We also have in Azure a lot of higher level languages. We have this bicep file here. Bicep is a domain specific language where we can describe our deployments. We can see here we have our primary, our secondary, and all the other components of our deployment defined in this file. What Bicep can provide, it can provide a lot of tooling. For example, let's take a look at the Bicep visualizer, where, for example, we have a graphical representation of our deployments. Here is our primary instance, and here is our secondary instance with all the other firewall rules and administrator definitions and such. So that from here we can actually even deploy our Bicep file and get everything up and running in a true infrastructure as a code environment. Actually, Bicep can generate both Azure ARM resource management templates, but can also generate, for example, Terraform scripts, right? So we can set up our environments in a fully kind of automated manner here. Okay, so once we deploy the environment, we have a simple Python app here, which is opening up a connection using, again, Entra ID as an authentication mechanism And then we are pinging every second with a very simple query, querying some system tables here to print out the primary IP of our primary server, the standby server name and such. And what we want to do is basically in between executing this server restart operation, which is simulating a failover. It's a forced failover actually between the primary and the hot standby server, and look at how the application is behaving to that. So we already have the application running here. As you can see, it's printing out my user, the primary IP of the primary. So it's 0.6 and the standby name. And we see we are hitting this every second, and in between we are executing this hot standby server test, which is forcing failover between the primary and the hot standby. In a second here, we will see the operation restart. Here we go, and here we go. We are starting the failover, right? So we are losing the connection to the primary, and we will see that in few seconds, usually is taking around 30 seconds to automate this. We should see the connection restarted. Let's wait just a few seconds again. And around the half of the minutes here, we should see the new connections coming in. Here we go. Now we have the connection to the new primary, which is 0.4 as an IP address and has a new standby name here, which is now up and running. So we have successfully failed over between the primary and the hot standby with around 30 seconds of downtime from an application perspective.
So local HA, it's easy, relatively easy to implement, and pretty straightforward in terms of failing over from our primary to the secondary with practically zero RPO and very low RTO. We are seeing those 30 seconds around of application downtime. So let's switch now to the Geo Replica setup where we can protect our systems from losing an entire region. And we will do that by creating a brand new replica in a different region. This is going to be asynchronously created because, cross-region communications cannot be synchronous. Otherwise, the latency will actually impact the performance of our primary copy here. And then we can use those secondary copies in a different regions for many scenarios, like, for example, offloading read operation or, reporting whatsoever, but also from a disaster recovery perspective, with the ability to fail over our primary region to the secondary region and keep our business up and running, even when we are losing an entire region in our system. So what we will see now is effectively how we can easily set up this.
Okay, let's look at the second part of the demo here. In addition to the local kind of synchronous replication that we had to provide a high availability at region 1, we are adding now a new read replica in a different region to enable multi-region disaster recovery scenarios. And between our region 1 and region 2, we have our synchronous replication stream, and we can demonstrate also how we can fail over from region 1 to region 2 in case we have a regional failure here, and potentially fail back the moment we have fixed our region 1. Okay, let's take a look at our demo environment here using Azure Data Studio right now to connect to both our primary, which is our writer version of the virtual endpoint, and to our replica using our reader version of the endpoint. Let's make sure that we are actually connected with the right endpoint. So I'm connecting to the writer with this one. And I have a second window here where I want to make sure I'm connected to my reader and to the same test database that I'm using. Okay, so if I query my IP here for the primary is 1047.04, and we can still check our application slots. We have two because, again, one is for the hot standby server, synchronous replication on the same region, and this is one, the Geo Async replica is the replication slot for our read replica in a different region. So we can do a quick check and try to create a test table in our primary here, inserting a row. And if we go to the replica, we can see that data is already there. Actually, as we're connected to Replica, we can query our system tables views here and see that our Replica here is a different, of course, IP address is 10.27.04. Is the primary info for this Replica are the ones that we already know. This is actually in a Replica state is synced, and we have a certain lag here, which is of course changing. And actually, lag doesn't make a lot of sense when primary and secondary are fully synced. It's when they are not synced that lag is an important indication for us, but it's generally with below few seconds. Okay, so let's see now. So we have the two primary and secondary Replica running, and let's take a look at a slightly different version of our test application here in Python. So this time we are connecting to both primary and Replica using the same app, because we want to again extract system info from both sides, right? But other than that, again, we are pinging every second our backend servers on both ends and print out and make sure that things are still working. Okay, so while we have our application up and running here, pinging both our primary and our Replica to get the system information, we will see now what is the workflow that we go through for this demonstration. Essentially, the first operation is failing over from our primary to our geo read Replica, right, which is a different command than the previous one. We can see that now we are promoting the Replica, which is our secondary here, to switch over as a new primary, and we are forcing this operation right now as we move. So as we force this, it is going to ask us if we are very sure to do this, because this is a pretty painful operation. Pull up, and then the forcing failover between primary and secondary will start. And we can see that the app is now, it has now started to experience some connectivity issues, right? At what's going on at the portal level here, we should see here in the replication page that now the secondary is actually the new primary, while the primary is Replica. And of course, the status is still updating between the two. So what we see here is that for the duration of this first phase, we have in our virtual endpoint, both for the reader and the writer, we are pointing to the secondary until the old primary will be in the state of being the new read Replica, right? And along the way, we can see that the application can still connect to the new primary, which is the 10.27.04, right? And in waiting for again the new the old primary to become the new Replica, but the application itself is definitely can be up and running. It can start executing queries against the new primary, which is the old secondary actually. And now after another while, we now have the full setup in place with the secondary, which is our new primary, and it's the writer, and the old primary, which is now the Replica, is also picked here in the second list, and the two are fully in place. And if we look at the application is again query both primary and secondary with two different IP addresses here. We can see also that the operation has finished here, right? So now it's time to actually revert back that operation. We have fixed our initial kind of primary region, and now we want to switch back effectively from the new primary, which is the secondary region, back to the previous one. So we can start again this operation, and we can take a look at here our application. Here we go. Now application has interrupted the connection for quite some time. We can see that in just a few seconds we should be connected to, here we go, to the application back again, right? And if we look at our portal, now we should see that the new operation is in place, right? So the primary now is effectively in the primary role here, right? And while the secondary is still updating its role back to the replica, we have the virtual endpoints right now that are pointing again to the same new kind of primary server, and for the duration of the operation on the secondary, which will bring back the secondary as the read replica role. And now we have the application back in place with our primary and secondary servers up and running with the respective IPs here, 1047.04 and 1027.04, and the replication stream are back in place. Yeah, and that's basically the demonstration that we can fail over from our region 1 to a secondary region and fail back, and the application will get minimal disruption between the two.
Okay, so both local HA and geo redundant setups, we are seeing how to create the two setups very easily in Azure Database for Postgres. Postgres, last but not least, with backups, we can enable geo redundant backups, and with basically click of a button here or with a specific API command in CLI and such, and we will automatically basically transfer our backups from our primary region to a geo-paired region, where at the opposite we can actually restore and take those paired backups and create a brand new copy of our entire system in a different region in case we completely lost the previous one. Right, so very simple and very effective, but typically both RPO and RTO of this solution are going to be much higher than the previous ones. Okay, so you can get a lot more resources. It's following the links here on the page. You can go to the homepage of the Azure Database for Postgres product, go to the doc, or to the various social media pages that are talking about our service. And also ask questions directly to the PostgreSQL team in Azure if you like. Or there's also a feedback page where you can, again, ask for new features, new capabilities that we will introduce in the service moving forward. Okay, so thanks a lot for your time. Hopefully today you're seeing how Azure Database for Postgres can let you create mission-critical deployments with relatively kind of simple approach, but very straightforward and very durable characteristics for you.